Hello. We are live once again, and of course, once again we are having camera issues out of nowhere. So bear with me one moment while I hopefully get that resolved. I suppose I should have been concerned when I launched this and Twitch told me it was having a tough time starting Twitch Studio. That should have been my first clue that something wasn't quite right. Uh, and that does indeed appear to be the case. So, yeah, all right. Well, we may just go, we may go faceless here. And you'll just have to look at the giant maw of that worm for whatever reason. I apologize. I do not know why this keeps happening. It is very concerning, but I don't think there's a ton that I can do about it at the moment. So that's all right. So we're gonna move on here. Welcome to part 2 of our discussion on Cypher. Do want to point out we do have a follower goal kind of pinned to the bottom of the screen there. Shouldn't interfere with the real estate much. As I mentioned last time, really need your support and your help in convincing my daughters, especially my 12-year-old, that her old dad can actually have a stream and have more than a handful of people actually follow that. So really would appreciate it if you could follow, give us a follow. That would be totally awesome. So just as a refresher, I've got a picture up here on the screen. This is the basic model that we're using for the demonstration of Cypher today. We have customers who create customer orders. Those orders have customer order lines, and those contain the items themselves. So again, if you recall, think of this as your receipt, and these are the line items on your receipt indicating what you've purchased and so on. So again, last time we did some basic Cypher, some basic matching, showed how to get some properties, do some sorting, traverse a couple relationships. Today we're going to try to take a peek at a couple more complex things and show you some more of the features that are available. For the most part, I am going to attempt to keep things to the I cannot use my words today. Pardon me. Keep things to the standard for open Cypher, because that is the more supported, or give you rather the highest degree of portability between different implementations of your native property graph database. And if there's an exception to that, I will point it out as we go along. But I am going to try to stick to that for the most part. So, as always, highly recommend this reference card. It is extremely useful for creating your queries and just remembering how everything works. And the current version is always here at the Neo site. So let's jump into some topics today. So let's say what I'm really interested in today is I want to find a subset of my customers and I want to get some information again about their orders. Now, again, as a refresher, we did some of this last week, but if I'm interested in just how many customers have that identify as female, I can do a simple count like that. Again, remember, I can use this format and put the selection here, or I could write it as a where and move it outside of that customer node. So I have 422 customers who identify as female. And as we showed you last time, if I want to see how many actually orders that these individuals have made, I can write something like this, where I find my female customers who have made orders, and I return their name, and then I count up the number of orders, and I label that order count, and I'm going to order it again by descending order. So we're getting that aggregate grouping again. So I can see all of these customers and how many orders they made. So cool, that's great. But what if I don't want to know the number of orders? What if I'm interested in how large these orders were? I want the total sales amount. And I want that perhaps for every order. So let's take a look at how we could get that. So I know that the sales amount is a property of customer order. All right, and if I'm not sure about that, then I could do something like the type ahead in here is nice. It's not always spot on, but it is nice when you can use it, but don't rely on it 100%. Sometimes it does lag a little behind. So I can match customer order, return O, limit 2, for example. If I don't remember what those properties are, I can look at it here in a table format, and I can see, oh yes, total sales amount. That's the property here that I'm interested in. There's the order number, but total sales amount is, in this particular case, what I'm looking at. So if I am interested in that, I can create a query that looks like this. Find me customers whose gender is female, who makes an order, and give me the name of the customer and the total sales amount for that order. And then that's going to give me something like this. And that's okay. That's certainly correct. But as you can see, because I have customers that have made a lot of different orders, I kind of get this repetition, right? So you see Max shows up in my first 10 or so lines, then I have a bunch of Andre, and so on. And while certainly, I could do some post-processing to clean this up, right? Maybe if I'm using a Java or JVM type application, I could collapse these results into like a map data structure, perhaps, where the key was the customer's name, and then I put the sales amount into a list and kind of clean up the data for use that way. That would certainly be one way to do that. But we can actually do better right here in Cypher. So let's take a look at how we can actually get a list of the total sales amounts per customer as opposed to getting them one per line. So that's where this cool function called collect comes in play. We're going to see collect a number of times today. Collect is a very, very handy function that essentially does just what it sounds like. It collects values up into a collection or a list, essentially, of values. So if I make that simple change, instead of to simply say return collect O.total sales amount, instead of just saying return O.total sales amount, just by adding this collect, and it is a function, so you see I have these parentheses here, you'll see I get a very different result. So now I just get one line for every single customer, and I get a really nice list of those values that I can work with. So that's really, really helpful in doing it. And just like anything else, I can rename that. So I can call that collection sales amounts. And just like everything else, I get a nicer header on my result. Now, this is a fairly trivial use of collect here. And if I am interested, as we are in this example, sales amount for customers in a particular demographic. There are some other really nice handy functions that come with Cypher. And I'm going to demonstrate a couple of this for you now. I will pause for a brief moment just to give you a caveat. What I'm showing you here are fairly trivial examples, obviously. These are pretty simple queries, and I have a fairly small amount of data in this database. And so while you can certainly use many of these techniques I'm going to show you as is, I will also say don't be afraid to break down your more complex queries into multiple steps and potentially use some some back-end processing if you need to, right? That and I think that's a tip that goes not just for a graph database, but really for any database. I know that a lot of times there can be an inclination, a desire to want to write a really elegant query that returns you exactly the answer that you need to your application. But a lot of times, and again, this applies if you're connecting this to an application. Obviously, if you're just working as we are here in a console with the data, then you are more constrained. But very often, for more complex queries, particularly against really large data sets, I will definitely break those up, and I'll capture that intermediate result in my application. And then I will, use that to generate a secondary query, and that can sometimes be significantly more efficient. So, don't be afraid to do something like that. So let's look at some other functions we can use here. There are some built-in math functions that come with Cypher. So if I want to know, man, I am having challenges with the copy and paste today. There we go. So there's a sum function. So if I want to, instead of seeing the list of sales amounts that everyone made, I can actually sum those up directly. So now I can see exactly how much each of these customers has spent in total across all of their purchases. I could also change that to an average. And we could do an average of those. If I also wanted to, let's say that we go back to our original example here, I could return that let's give that an alias, so as sales, whoops. And I could do, let's see if I can do this right. So I always forget. So let's come over here to our reference card. And what I want to know is I want to remember what is the function to get the size of that collection. So a couple of ways we can do that. So I have functions are color-coded here in kind of this nice light baby blue. So I can see those are over here. And I can see there's mathematical operations here. Again, those are in my sort of green general one. I think the operation that we actually are interested in is here in the, so here's all of my list operations as well. And of course, we can always, so here we go, for list expressions, there we go. Yeah, it is size. And you can see we have a number of other interesting operations we can do. We can reverse a list, we can get a head, we can get a tail, and so on. So lots of cool things. So again, really handy to look that up. So, and I can also return the size of sales amounts, and we'll call it as number of orders. Whoops, and see here, because that was not actually defined here, because this is not yet available to me, and that's okay. But we can, if you want to use that later on, you could certainly do that. So what happens when I go off of my script, but again, just be aware there are a handy dandy number of functions there as well. Again, we could even throw it up into here if we wanted to. And there's the size of the number of collections that we actually have. So you can see Max made 10 orders, and Andre made 20, and Moses 10. Obviously, there are better ways to do this, but again, just showing you that size function off of a list. Awesome. So let's take a look at a couple of other things we can do here. I've shown you matching of string property values, exact matching. What if I want to find information about my female customers, but only where their sales amount is greater than 50? So we have those nice numerical operators as you'd expect as well, greater than, less than, equal to, greater than or equal to, greater than or less or equal to, etc. So here, very similar query to what I had before, except now I just want the item IDs in the case where the total sale amount for the order is more than $50 in this case. And I'll get back my item IDs. And so, that's just demonstrating a way that we can use these numerical operators to further refine our queries. So I want to now introduce you to a couple of other advanced concepts. We're gonna again use a kind of an arbitrary example here to show you some more advanced things you can do with a collection. So let's once again look at this example. So I'm expanding on where we were before, again, still using customers who are female who make an order where the total sales amount is greater than 50. And now I'm going to collect up all those order numbers. So very similar to, whoops, turn that two-way return. Sorry, I didn't paste my entire thing. There we go. So there we go. That makes makes a huge difference. So let's just run this, and we'll tell you what we're actually doing here. So in the beginning, it's very similar to what we saw before, right? So find customers identifying as female who make a custom order, and I want only those orders with the total sales amount is greater than 50. And for the orders that match that, I'm using this new keyword here, with. We'll talk about that in a second. But what I want is to take all of those order numbers and put them into a collection, essentially a list, and I'm going to call that order numbers. Now, with essentially allows me to start creating more complex queries. Whereas normally before we were returning that collection, what I'm saying is I want the database to execute this query here, and I want it to save this result. Everything that it used prior to this that's not identified in the with, I don't care about any longer. The database can go ahead and essentially drop that out of memory or otherwise clean it up as appropriate, based upon the internal implementation. But I need this collection here that I'm going to call order numbers in a subsequent portion of a query. So now what I can do when I have a collection is I can step through that collection, and we do that with the unwind keyword. Unwind takes a list and allows you to step through the items in it one at a time. So when you do that, you identify the collection that you want to step through. So order numbers is what I used up here. And I have to identify what I want to call each item in this list as I'm stepping through it. So I like to just use the convention where my collections typically end with an S, so I know that I have more than one of them, and I remove the S for the individual things in there. You can certainly do it any way you like, but I find that with more complex queries, this keeps things easy for me to remember. So I'm going to step through this, and I am going to run another match query. And I'm going to say I want to find customer orders where their order number is equal to this order number in this list that contain a customer order line that has an order, that has an item, and I want that item ID. So as you can see, this is very similar to the query we wrote before, and I'm going to bring that back up here in just a moment. So let me bring that one back up here, and we can compare them. So here you can see I'm getting essentially the same results, but in this query, I am not creating a collection and stepping through it. I am just saying straight out, walk this entire long chain and give me those item IDs. So I still want female customers making orders that are worth in total more than $50. Give me all these item IDs. So your question becomes, well, why would I write this? This is obviously longer, and it looks more complicated. And the short answer is going to be, again, it depends. Well, and of course, the most truthful answer is I wanted to illustrate here, as I mentioned, kind of a trivial example, how to use this unwind function to then walk through those collections you've created to perform additional, more complex queries as part of this whole. One reason you may want to do that, even in a fairly simple example, is something I referred to earlier, and that's to do with performance. So I'm a big believer in never trying to optimize prematurely, right? So I'm always going to try this simpler query first. And again, in this particularly small database I have here, I know this is going to work just fine. And we can see that, this only took 6 milliseconds. So it worked just fine. No problem. But if I have a database with billions of nodes in it, and perhaps perhaps tens of millions of customers making hundreds of millions of orders, now I've got to really be a little more careful, right? Because that's a lot of stuff. And again, this is going to vary potentially dramatically depending upon the implementation of your particular graph database. So you're going to have to play with things and see what happens. But bear in mind, essentially what's to happen is for anyone to resolve this query, the database doesn't really know what you want until the end, right? So what I mean by that is it's going to find customers that match this particular group, walk through to orders, filter out the orders whose sales amount is only greater than 50, and then it's going to go back and grab the item and return for you just that item ID. But in doing so, it's very often aggregating and holding, very often in memory, a lot of data about everything in this query until the query completes and returns this result. And if you're going through a massive amount of data, that could be a problem. So as I showed you here, that's where sometimes breaking this down can help. Because remember what I said here, when I'm using this with, I've now told the system that from this point on, I'm done with everything prior to here. I don't care about this customer anymore. I'm not going to use that data in the next portion of my query. So the system no longer essentially has to store this in what is effectively its working memory. So if I'm going through a massive amount of data, yes, it has to keep a list of all of those order numbers, but a list of numbers is not expensive to store. Where I might have a lot of data in customer and in customer order, and that is potentially kept up here in memory in case I need it. Where here I can explicitly telling the system I don't need to worry about that. And again, one of the ways I can show that is here. If I say I also want to return that customer.name, it's going to tell me that I can't do that because this variable C that I had up here, it no longer exists in this part of the query. It's not visible because the only things that are visible in this second match are things that I brought with me explicitly from the first match by using this with keyword, right? So if I wanted that, I would also have to have some other collection here or a return of that customer's customer's name. So if I wanted that, for example, I could put that into a map, for example. I'll show you that in a moment. Maps are not, I believe, a standard part of the Open Cypher specification yet. They are implemented by some vendors, so Neo4j being, chief among them. But as any programmers among maps can be extremely useful functions. Let's take a look at something else as well. So the exact syntax may vary depending upon your database implementation again, but almost every database will have some version of profile and explain to again help you understand the performance of your queries. So first let me go back here and fix this one. So in this particular case, if I say explain, it's not going to run my query. It's just going to explain to me what the query profile looks like. So if I make this a little larger here, you can say I don't get any results, but it explains to me what happens. I know this is a bit of an eye chart, so I can make this a little bit bigger for you. So, and I'm not going to attempt to go into tremendous detail. All the means here, there's a very in-depth portion of the Neo manual that explains what these particular functions all mean, as there should be for whichever particular implementation you're using as well. But just peeking at this, we can get a lot of information, right? So I can see here that the database is going to find all customers first by using the customer label. Let me get an estimated count of rows. And again, we see here, as we suspected, it's going to filter them by that gender that I was looking for. Then it's going to walk that relationship, this anon35, that's an internal variable it's using to keep track of this relationship. As you see in here, in RMakes, I did not assign it a variable. The system internally needs to keep track of that. And then again here, once it does that, it's going to do another filter. So meaning it's going to look at all of those customer orders, and it's going to make sure that it's only pulling back the ones that match that that criteria that I provided, right, which is greater than 50. Then it's going to it's going to aggregate those into a list. And now this is interesting here. Right now, you see it branches here. So it's now able to start multi-threading things. It's going to do two things essentially simultaneously. It's going to start unwinding that list. And as it unwinds the list, it's going to start running that other query over. So it's going to start finding customer orders that match that order number. And once it does that, it brings those results together, walks out that relationship, does the filtering once again, and then eventually comes back and returns the information that I need as a result. So we can see, again, even just sort of looking at this, we're definitely down to 10 rows here. We're getting we're dumping a lot of the other rows, the other data that we had before. So if we run the same explain on this guy, and this is the same query, except again, we're not using the collect, we're actually just there we go. So now we see it's a straight line, right? It's a straight line. There is no parallel processing happening whatsoever here. All the first things are very much the same: finding customers, matching gender, walking a relationship, filtering by the amount again. But now we're walking more relationships. We still have a couple hundred rows we're walking through. We're still up to 200 rows. See, and we can see here, even at the very end, we're producing results. We're walking through over 200 rows. the system is holding more information essentially in hand during this query than it is my other query. And if we go back to here, we very quickly get down, we're under 200 already on about our fourth step. And now down here, we're in the teens, right? 14 rows. So again, with this really small size database, actually using that particular construct or that approach of collecting up some intermediate value and then using that as a parameter in our subsequent query isn't a super big deal because we have a small amount of data, but on really large size production things, it can make a huge difference. But again, as with everything else, test it first. Try the simple thing. So as promised, I do want to show you one other thing. I want to show you maps. So we'll run this real quick. So here, very similar query to what you saw before. Still again, female customers making orders, walking all the way down to the line item, only sales amounts greater than 50. But now I want to return, this is a map construct here, these curly braces. Again, last time I checked, this is not yet supported in the full open Cypher specification. I know there's a push to get it supported, but it may be supported by a vendor. It's clearly supported by Neo4j. And here what I'm saying is I want to return a map. So for a map, I give things a key and a value. So I'm saying I want to call something order number, and its value would be the order number from my variable O, and I want to map that to the I want to give the price of the item and call that item amount again here too. So here you can see I'm getting those map results, and of course we can use these map results in intermediate expressions as well. So here back in our reference card, we can see, again, now how to create the map, but we can see as well that we can actually access properties in the map later on. So here they're using that with construct again, and then accessing values inside of the map. So they call this map P, and it's a nested map. So one key is person, and inside of person they have a name. So here you can return the map's person key and the value of name. So a really handy construct for building out more and more complex queries. Great. So we've gotten through all of that. Again, as always, please help me out with my follower goal. Really need that to keep this going. Please reach out with any questions, any additional comments, any thoughts or topics you'd like to see addressed here. We're going to try to bring some special guests in relatively soon, but really want your feedback in terms of what you're looking for. I'm going to see if I can get this camera working again, and I look forward to talking with you all next week. Thanks for coming in. I'm Clark Richey, and I'm the Graph Guy.